Alright, hello everybody and welcome back to Environmental Science. So here we do alternative energy and other forms of energy too along the way. So we talk about the history of energy and industry and how we got to where we are today. We look at transformations of the Industrial Revolution and combustion. We will look at fossil fuels, hydrocarbons, the different kinds, where they come from and how they're used, how they are different or alike. And then finally, we look at alternative energies, right? Renewable energy sources, which as we'll see, renewable is not the same as alternative. Not quite, but we'll get there. Okay. In the meantime, sections, right? We got energy and industry. Our historical section, we talk about combustion, especially of fossil fuels. Get our hands dirty. We do electricity in all forms, and then alternative energy is last. Cool. So first section is on energy and industry. So going back to our sort of deep time thinking. Okay, so over time, human beings have strived to create better technology, right? And there's a lot of different answers to this question of, why or what is spurred it on. We're going to take the kind of simplistic but true view that there's two reasons, right, why people have done this, right? The first was to be able to kill each other, and the second, which we're going to be focused on, is energy, right? The vast majority of technological process that has taken place, right, up until very recently, was in these areas, right? Either better and better spears to be able to hurt each other with, or better and better fire, better and better energy sources. These are what push and transform the world. Okay. So energy. We've got our formal scientific definition here, if you want it, right? A measure of the capacity to do work, which is not a very good definition because it's circular, right? Work is a way of transferring energy, and energy is a way of doing work, or cause change. If this definition seems kind of flimsy and useless, it's because it is, because there is no perfect definition for what energy is. A definition just exists to be useful. It's not actually eternally true. Sorry. I like this definition better, right? The non-stuff, in stuff, the make stuff, do stuff, say it with a little twang, and everybody remembers that. Okay. The original source of energy, right, for our entire planet, right? If you trace it back all the way, where does it come from? It's going to be the sun. Okay, right. The sun is ultimately what delivers energy to the earth, right? Delivers energy to the plants, which go on to feed the animals and everything else, right? This is where all the energy is coming from. This is the, stream output of energy, and if we could only harness more and more of it, we would be doing really well, but we can only get a tiny %, and that's kind of enough, because it's just an absolute fire hose of energy coming out, right? There's more than enough energy to go around. Animals historically are going to be our first place to start as far as how human beings have harnessed energy over time, right? Pack mules being able to haul things for a long distance and carry them, right? And they eat the plants, which are powered by the sun. Oxes being able to plow, right? Being able to cultivate farmland much more efficiently than people can, right? And for the vast majority of human history, like this and fire and maybe a couple of the limited technologies we'll look at was all you had as far as energy. And if you owned a lot of these, that was good, right? The next one, relatedly, okay. Animal tongue, right? So for herbivores specifically, this is not like carnivores whose poop is much nastier, right? Herbivores, it is not as nasty. It's why horses can go anywhere, and it's not really as big of a deal because it just kind of blows away, right? This can be used as fuel for fires. You can even cook with something like this, and people do, right? Other things, sailboats, right? Hey, so it turns out wind energy was there all along. You just didn't realize it. It was in the sailboats, windmills. These are foreshadowing what we're going to see eventually, right? Which is as the last step of the process for whatever energy generating system, you turn a wheel, right, to generate electricity. A lot of times these would be used for grinding corn or wheat or whatever, right? And these are sort of oddly ominous. You should be a little bit scared of them. Okay, mill would be the next one, right? So, you're in England or whatever, right? A lot of our common law is derived from English common law, and it rains constantly, and you've got stream running through your property, and you put, a wheel on there, right? And it turns, and now you can grind as much corn as you want, right? Turning a wheel, being able to harness the environment as it is to be able to generate energy that way. Now, the big change where this starts to get different is with 1750 and the start of our Industrial Revolution and this person, James Watt. So ultimately, his steam engine, the original design, is about 4% efficient, right? And generates about 2 horsepower, right? And we'll see what that actually kind of means in a minute, right? The vast majority of the energy generated by coal, which is what fuels it, is lost, right? It's only 4% efficient. The other 96% is lost, and yet you don't have to feed this, right? You don't have to get a horse doctor. You can build it out of materials that you have. You know, you don't have to build steam engines out of other steam engines the way that you do with horses. And yeah, this is just a lot better. This kickstarts the entire Industrial Revolution. Horsepower is equal to about 750 watts, right? It is measured as the ability of, you know, some engine to be able to lift 550 pounds, 1 foot per second, right? Which is, you know, thinking about it in human terms, that'd be a pretty good lift if you could do this. I guess you'd be as strong as a horse, right? Horsepower of vehicles has gone up steadily over time as technology has improved. So in case you're curious, right? The original steam engine was about 2 horsepower. A typical car might be 200, and, you know, cars that are built for speed might be way higher, into the 4 digits, right? As a result, right, since his steam engine and others were powered by coal, which is energy dense and can be burned and releases a ton of energy, you have this explosion in exploration, right? Through Appalachia here in the United States, right? You know this as coal mining territory, like in West Virginia, right? And all throughout England. In fact, the entire science of geology was essentially spawned out of the need to go out and find more coal deposits. And it turns out these things are not randomly distributed. They're not just, you know, sort of mixed about like a chocolate chip cookie into the world, right? They're extremely concentrated into these coal beds. And you go out, you make maps, you can figure out what's going on in the subsurface and find the structures, right? And you can figure out where the coal is going to be before you actually have to dig down there, and that's really, really useful, and an entire science develops as a result, right? Coal has tons of uses, so it includes heating people's homes, powering those engines, and yes, making steel, which is then essential for producing all those other things. So you have this sort of explosion chain reaction that goes on, right? So you have coal and you have these engines, and the coal gives you the energy that you need to build steel, which lets you make better engines, which let you make more steel, which let you make trains that bring in coal from even further away and better trade, right? And you sort of have this cycle which leads to, you know, an explosion of the Industrial Revolution and of machine production, which has kind of never ended and could probably never happen again if this thing were to go topsy-turvy. Could never do this again, so be careful. Applications, right? Farmers could use it instead of having to use animals. You can use steam engines and steam-powered machines on the farm, get much more out of the land. Trains, as we've discussed, right? You've got like a little coal furnace in here, powers the steam engine, which powers a train. Mass production of consumer goods. Like what? Like clothes, right? Things made out of cotton. You have the entire, for example, south of the United States plantation economy where they were producing cotton and exporting cotton and making $1 bazillion out of it. And it wouldn't have been possible without the advent of machines, which were able to mass produce clothing, right, as a result of cotton. At this point here in 1880 is when somebody finally had the bright idea to hook that steam engine up to something that spins a wheel and generates electricity, right? This thing called a turbine. And at this point, you are able to use electric power, and, you know, you have your power generating station, and all of a sudden you can turn on, you know, light bulbs at the New York Times and in Wall Street, and all the jackrabbits there can work extra late, and okay, yeah, we'll keep that part short. Development of electricity, right? At the same time, you have this first hydroelectric plant, right? This first dam, which is able to spin a wheel and generate electricity up in Wisconsin. It is pretty feeble compared to the other dams, but this is the first one. So what do you expect? Okay. Electric transmission, right? Transmit, like to be able to send it elsewhere. Happens for the first time. This is a Portland, Oregon station, right? And we can see the old kind of power lines, right? We're able to transmit electricity 15 miles away. Doesn't sound like that much, but this was the first time it had ever happened. So you should be impressed. Please be impressed by this. Okay. Around this same time, right, petroleum starts to come online as not just what it was, which was a fuel for like lamps, right? People were using whale oil, and that was bad because they were running out of whales. which is terrible to say, but they were, right? And so they start using petroleum as a result. Somebody has the idea to turn it into gasoline and to use it to fuel an automobile, right? And now we have the other part of this transformation, right? So electricity is one part, and then cars are going to be the other, right? You have Henry Ford building these production plants where he's able to crank out these things by assembly line, right? So instead of one person building the entire car from scratch, as Thomas Jefferson intended on the homestead, right? Instead, you have this assembly line. So each person does one thing. One person puts the tires on. The next person attaches the headlights. The next person does the steering wheel, right? And you as a person are only focused on that one thing. And so you can make tons of cars, right? And the price for this one, well, it was even more expensive in like $1908. The price falls sharply over time until, 100 years ago, 1924, it's equivalent to like a $5,000 car in today's dollars. It's a pretty sweet deal until you realize that this thing has no safety features. I don't think it could go faster than like 30 miles an hour. Tires are not really great and wear out. Okay, there's no air conditioning, there's no windows, no radio, whatever. Okay, but anyway, this was a pretty sweet deal, right? And a lot of people could afford cars that didn't have it before. The combination of those two factors, right? The automobile and electricity is what allows the cities in America to explode economically, right? People are starting to move into cities and now they have a car, right? So they don't have to live in the urban center. They can afford to live a little bit further away and drive their car in. And as a result, right, the city starts to sprawl. It starts to spread out. And so more and more people in it need cars and start living further away, which means that people who move to the city need cars. Okay, so cars take off and energy use doubles in the United States about every 10 years, right? So our crossover point, remember we said for the whole world, the crossover point was like 2005. The US reaches that point about 100 years early, right? Somewhere in the early 20th century here, where we have more urban population than rural, exactly as the automobile starts to come online. Percentage of people living in the suburbs explodes as well, and it starts to look like this, even the black and white. Okay, vehicles, right? We notice that this explodes right about the time, so 1908 with a Model T, right? The only thing that caused dips in here are the Great Depression and World War II. Other than that, it has been this explosion ever since. Notice, right, also that our energy use, right, we said it doubles every 10 years, and so we get an exponential curve, kind of like the exponential curve that we got for population, right? We're going to come back to some of the details on this later, but just notice that the curve on this one is exponential. All right. Japanese believe in World War II, moving ahead to like the 40s, that the US was trying to cut them off of oil, which they desperately needed, right? They were choked off of it. They preemptively attacked Pearl Harbor, and, the rest of World War II, I'm just going to assume you're familiar with, but in large part driven by energy demand in Japan. Japanese demand for oil that they did not have and that they thought the Americans were trying to cut them off of. Post-war, right, so during the war, nuclear energy technology is developed. Post-war, these turn into nuclear power plants, which have all sorts of issues and costs, which I'll put in a note, right? Next thing on the timeline, 1970s, you have this giant spike in oil prices and this kind of crisis. You have gas lines and people waiting forever to be able to get gas. That shortage, as accompanied by the price spike, which is caused by conflicts in the Middle East, is followed by glut, right? And prices don't go back up until much later. Price of oil today is about here. 3 Mile Island is a big nuclear disaster, the biggest nuclear disaster in U.S. history, considered a 5 on the 7-point scale. Only Chernobyl and Fukushima are worse. Major setback in terms of nuclear energy. However, notice that nuclear is still kind of steadily rising after the 50s and constitutes a major portion of renewables today and is especially important in Arizona. This just shows the amount of new energy being produced. Notice that solar, right, is a huge fraction of the new energy, right? Just to clarify, these are additions to. In other words, of the new energy being generated in the United States for Americans, solar is a gigantic part of it. However, we are still doing a lot of things to export oil and natural gas to other places overseas, right? And with that, we are going to move into a focus on hydrocarbons and combustion energy.